Within this module, we are going to study several different types of time value of money calculations. You will need to be able to learn compounding and discounting, in other words, calculating future value and present value of a lump sum and of a series of cash flows. Apart from this, you will need to be able to calculate future and present value of annuities and perpetuities, and also calculating the period of time which is required in order to achieve certain financial goals. So this is what we are going to study in the remaining video lectures. And we will start with the analysis of what interest rate is, what are different types of interest rates, and what are different ways in which we can apply a certain interest rate, a rate of return, on the initial invested sum. So interest rate, as we've covered in macroeconomics, interest rate is the cost of money. It can be cost of borrowing. When you get a loan, this is what you will pay on top of the original amount you've borrowed. It can be a rate of return on your capital. It's a rate of return on your savings, for example, or investment. This is what you will get on top of the original invested amount that someone else will pay, someone who borrowed your money. You can also think of the interest rate as the discount rate. We will have a few discounting formulas today. We'll learn how to apply it to discounting process. You can also think of the interest rate as the opportunity cost. This is what you might be able to earn in an alternative investment. In all of these scenarios, regardless of how exactly you apply the interest rate, it is a rate of return which shows the relationship between present and future cash flows. They have different value, as we've learned, and interest rate is what allows us to compare them. Later in your course of studies, you might refer to this specific formula, which tells you that the nominal interest rate is equivalent to the real interest rate plus inflation rate. This is the version which we learned in macroeconomics. And real interest rate can also be split into two components: real risk-free rate plus a risk premium. You might come back to this formula later when you study other finance modules. What you need to know now in this module is that we can apply an interest return in two different ways: as a simple interest or as a compound interest. Simple interest is the interest paid or earned on the original amount or principal only. Simple example: you pay, let's say, £100 into your savings account at 5% return. At the end of the first year, your end balance will be £105. You've earned £5 during this year. At the end of the second year, your balance will be £110. You've earned the same amount, 5% on the original amount only. At the end of the third year, you've accumulated £115 because you still earned 5%, £5 on the original amount, on the principal only. This is what simple interest is. However, the most frequent type of interest you will come across in finance and accounting is the compound interest. Compound interest is the situation when you pay interest not only on the principal amount borrowed, on the original sum, but on any previous interest which accumulated as well. Again, let me give you an example. You saved £100, you earn £5 during the first year at 5%, your ending balance is £105, and next year you start earning interest on this amount now, on a higher amount, which means that in the second year your earned return is slightly higher. So during the second year you earn £5.25p, which you can add to your original amount. In the third year you earned 5% on this amount, not on £100, but on the starting balance, and so on. In other words, your capital grows faster. The difference between these two series might not seem like a lot. You only get a few pennies difference in this particular situation. However, it does accumulate over time, especially when we talk about large sums and significant periods of time. And in reality, compound interest can lead to incredible financial results over the longer term. Let's have a look at some formulas. Simple interest first. This is the formula which you might need to know. It tells you that the simple interest can be calculated as the present value or initial sum invested times the interest rate for a certain period times the number of periods n. Very simple. Let me show you an example. Let's imagine that you deposit £1,000 in your account at 7% simple interest for 2 years. What is the accumulated interest or return which you've earned at the end of the second year? Very simple. Let's apply our formula. Present value, the original sum. We use color coding here so that it's easier for you to keep track, to relate different numbers. Present value of the original sum, initial sum invested, is £1,000. We'll need to multiply this by the interest rate, which is 7%, 0.07, times the number of periods. In this case, it's 2 years times 2. And basically, this formula tells us that during this period, we would be able to earn £140 return. This is the simple interest. In fact, very simple indeed. And now let's start applying this idea to value different types of cash flows. Let's try to evaluate future value of a certain lump sum investment based on this simple interest. Future value is simply the amount which a certain sum of money invested today will be worth at specific time in the future. And to calculate future value based on a simple interest, we take the present value, the initial sum and initial invested capital, and we add the simple interest we've earned. Or alternatively, we can apply this formula. This is the formula which you will use more frequently. Future value is equal to the present value, initial sum, times 1 plus interest times number of periods. Again, we use color coding to make it easier for you to keep track of different numbers. We're analyzing the same example, same deposit, £1,000, earning 7% simple interest for 2 years. We've calculated the accumulated interest, £140. What is the future value of our deposit at the end of these 2 years? We simply add up the original amount, £1,000, plus what we've earned. So eventually we will have £1,140. Or alternatively, we can apply this version of the formula, again plug in all our numbers, and we will get the same amount, 1,140. This is what simple interest is. Simply take the sum, multiply by the percentage return times the number of periods. What is more important, however, is to understand how the compound interest works, because this is what is happening in reality in majority of cases. So as I mentioned already, compound interest is the interest on a loan or deposit, which is calculated based on both the initial amount, initial principal, and the accumulated interest. So we are trying to grow our capital from the present point in time to some amount in the future. And here, the interest rate and the number of periods will play an important role. This is because the future value of any invested capital, the present value of any invested capital, will depend on our interest rate, now raised to a power which is equal to the number of periods. Compare with the previous formula. Previously, we multiplied interest by number of periods. Here, we raise it to a power which is equal to the number of periods, number of years. In other words, our returns here, our capital, will grow exponentially, not in a linear manner, but exponentially. And this is how you can get really, really rich. Again, let's have a look at a few examples. Our initial deposit, invested at 7% for 2 years, as before, will result in a larger sum. Not £1,140, but £1,144.90. Again, this might seem not like a significant difference, but if you apply compounding these exponential powers over a longer period of time, the returns will be dramatic. Let's have a look at some more examples. How did we actually get to this formula? Let's have a look. Let's imagine that you simply put £100 into a savings account. You will earn 10% return on this. It will be credited at the end of the year. So at the end of the first year, you will have £100 principal plus 10% interest earned, which is equivalent to £110. How do we calculate this number? What is the formula involved? Future value in the first year is equivalent to the present value of your principal, £100, times the compounding factor. The compounding factor is simply a unity plus your interest rate. At the end of the first period, there are no powers involved. You only add 10%, and that's it. And your future value will be equal to £110. Very simple. After 1 year. What is happening after 2 years? Future value in 2 years had compounding factor applied twice. So current present value, what we've earned, the interest we've earned during the first year of investment, and then we add the same amount earned during the second year, which means that our future value is going to be £121. We have these terms appearing twice in our formula, which means that we can simplify it. And instead of writing it down twice, we simply raise this term in brackets to power 2 during 2 years investment. If, however, we invest for a larger period of time, for n years, we can consolidate all our n compounding factors which we have during all of these periods, every single year, year 1, year 2, year 3, or whatever number of years, year n, we will have the same compounding factor. And we can consolidate them together into a simple formula. We take unity, add our interest rate, and raise to power n equal to number of periods. This will give us our future value. Present value times our compounding factor will give us the future value of any lump sum investment. Lump sum means that we invest only once. Please memorize this formula. This is one of the most important formulas in finance. You will need to use it all the time. Even if you are given formulas in exams, believe me, you will need to rely on this so much that it's just quicker to learn. You need to know this formula as a professional. Future value is calculated as present value times your compounding factor raised to power n, number of periods between now and future payments. When you will start working in the industry, you might be able to use the ready tables. There are financial tables which give you the future value of £1 calculated for different number of periods and at different interest rates. So sometimes you might be able to save you a little bit of time and just rely on the ready tables. Just be aware that they exist. And now the most interesting part, the power of compound interest. I told you that compound interest can actually generate dramatic returns. Let's have a look at how it works. Let's imagine that we invest a capital equal to £1,000. This is your lump sum investment. Let's check how it will grow over time. 5 years, 10 years, 15 years, or 20 years. The financial result will, of course, depend on the rate of return, let's say 10, 15, or 20%, and the time period. Time is critical, and time is the most important element in investing. So you can see here that after 20 years, your initial £1,000 will grow to more than 6,000 at 10%, 16,000 at 15%, and more than £38,000 at 20%. And obviously, the longer you keep your money invested, the higher your capital will be. When you invest for a long time period, 20 years, your £1,000 will grow to some amount between 6,000 and 38,000 because of the accumulated interest. If this growth of your capital doesn't impress you, let's have a look at a different example. Let's invest £1,000 as a lump sum, plus also add £100 every single month. So you work a little bit, you save a little bit of money. Even after your graduation, you might be able to save a little bit of money. And this small addition will lead to dramatic changes to your financial result. Our period of investment remains the same, our returns remain the same as well. However, this small addition will lead to dramatic changes. You would be able to accumulate somewhere between 78 and £282,000. So if you start investing in your 20s, literally work over summer, save small amount, invest it, and then just try to save a little bit, a small proportion of your current income in your 20s. By the time you reach my age, you will have quite impressive capital. However, what is the most interesting is this graph. Here in this graph, I've taken an intermediate rate of 15% and I've shown you how this scenario will develop, how your capital will grow. So I've used these data from this table. And you can see that the vast majority of returns actually comes from the compound interest. This is what you've invested. This lower part of the graph, dark navy part, 25,000, this is what you put in. This is what you've actually invested over this period. £1,000 in the beginning and then £100 for 20 years. And this amount, this part of the graph, bright blue areas, bright blue bars, 142,000 is your profit. This is what you've accumulated due to the compound interest. That's the power of time in financial markets. That's how much people lose when they actually don't invest and don't attempt to spare any money and don't think about their financial future since early years. Another example, which illustrates that in investment, the time is an essence. And this is particularly applicable to people like you. Let's imagine that you don't have any starting capital at all, not even £1,000. However, you are young and you have plenty of time at your disposal. Let's imagine that you can only afford to save and invest £100 per month. Does it seem like a lot? I don't think so. Strictly speaking, most of you are able to earn this amount by simply working part-time for one weekend per month. Let's have a look what you might get if you try to save £100 per month for a long period of time. We'll see again that time in financial markets is the most critical thing. If you start doing this now, by your retirement age, you will have huge amounts of money. Apparently, the rate of return on your investment will make a difference. Nevertheless, the results will be spectacular anyway. For example, if you manage to get only 10% return, by the time of retirement, you will have £1,746,000. If you manage to get 15% returns on your investment, you will get nearly 14 million in your bank account. This will be the value of your portfolio. If you manage to reach this amount, 20%, you will become a multimillionaire, £123 million, more than enough. As you can see here, the capital grows exponentially. That's the power of the compound interest. However, it needs time to fully develop because the initial growth, as you can see, is very small. For a long period of time, your capital increases, but not at a very high rate. It's barely noticeable. However, with each further year, your profit will grow bigger and bigger, quicker and quicker. It will grow exponentially. That is why, unfortunately, if you want to become a millionaire by investing, say, in a stock market, you won't become rich quickly. I'm afraid this is not the case. However, you can become rich and very rich slowly if you are patient. I do hope that this example will inspire you to start thinking about your financial future right now, because you have all of this time to wait. And decisions which you make now will make all the difference to where you will end up in your retirement age when you become older. Maybe you were not aware of this quote by the legendary Albert Einstein, who said that the power of compound interest is the eighth wonder of the world. He said that compound interest is the most powerful force in the universe. He who understands it earns it. He who doesn't pays it. Compound interest helps people to create wealth, and you can do this too, as long as you know the rules of the game, of course, and as long as you are patient. Another example, let's do an experiment. Let's imagine that we have two individuals. We have Maria, who started investing since young age, like your age. Just imagine you've graduated, you've got your first job, and you started investing £500 per month at 10% for 10 years, and then you stop. This is all you do. At the early age, you've just invested £500 per month. So between, let's say, 22 years old and 32 years old. And we also have George, who started investing later, in 10 years, after Maria stopped doing this. He also invested the same sum, £500 per month, also at the same rate of return, 10% per year, but for 30 years. In 40 years' time, what do you think happened? Who do you think had more money in their account? Stop and write down two numbers, one for Maria and one for George. How much money do you think they had? Who do you think had more money as the result of their investing efforts? Stop the video, write down two numbers, then continue. Ready? Let's check. This is the capital growth of these two investors. As you can see here, in 40 years' time, Maria ended up with just slightly more than 2 million in her account, while George only generated 1 million. This is still a dramatic amount. However, as you remember, he invested for 30 years, while Maria only done it for 10 years. She put in significantly smaller sum compared to George. She's done it earlier, however, and her financial result, her outcome, is twice as great compared to George. She has managed to generate nearly £1 million more than him. pounds or dollars, doesn't really matter which monetary units you use. The numbers will work the same way. She has ended up with a significantly better financial result. This experiment shows that the earlier you start investing, the more you'll be able to gain due to the power of compound interest. The more compound interest will be able to earn for you. The miracle of the compound interest needs sufficient time to grow and develop. Therefore, an investor must be patient and start early. I hope that I entertained you a little bit and you enjoyed these examples. And now let's proceed to learning some formulas which you will need to use in your future professional practice.